So today, the first topic is about FluxMotor parts creation within SimLab Sketcher. And to start, I would to underline the reason because we are used to and you should create your parameterized part in FluxMotor. In fact, the main reason is that the parameterized part enables the user to gain access to the optimization through and within FluxMotor. So you can see that FluxMotor is the concept design, is in the concept design in our e-motor design process solution, and we have several workflow and tools that allows automation and optimization around these design tools. So as you can see, with this presentation, we are targeting the rapid design exploration and ranking for feasibility study during the concept phase. So to enable this feature, we need a parameterized part within FluxMotor to be able to automatize and optimize the motor in a very easy way. And FluxMotor already offers a big part library, as you can see, for any kind of motors available. You can see just a part of the predefined inner magnets topology. And with their parameters. So each part already contains some parameters that you can use, but the user can create his or our customized part. So let's see how to do it after a brief review of the automatized process to which you have access then. First is hyperstudy. So we are talking about optimizator. So we have the access thanks to the parameterized part to hyperstudy and to the e-motor director platform. So FluxMotor gives the access to hyperstudy in one click, and it allows the user to carry out a screening of the parameter to evaluate the influence of them on the interested quantities. You can see an example here, a DOE and fast and simple optimization. In this example, there is the main goal is the weight reduction. You can see as the parameter can change thanks to hyperstudy. So the second tool is another solution that we developed over the years is the e-motor director, and it is a platform where an automatic platform that allows you to modify parameters on a motor and define and run a multiphysics workflow in few clicks. You can see from the image, you can just drag and drop the block and link them. Explore the results and browse all potential motors to get the best motor family of motors matching our specification. So let's start to have a look in the main topic. So how to create a parameterized part. So we have mainly three ways considering SimLab. So you can editing an existing part available in the inner magnet catalog within SimLab, import a custom geometry and parameterize it, or create a part from scratch in the SimLab Sketcher. You can see the three examples. And you can see how it is important to use the convert to sketch in the case of imported geometry, right? So let's have a look at the process and that the limitation constraints are there. So this is the general workflow. We have different steps, but the first one is to create the FluxMotor solution within SimLab. So you have to choose the FluxMotor solution and to create the solution. So the new solution will appear in the solution browser. But since it's a quite, a short process, but it made by many steps, we prefer to show you directly the video. Let me start it. So we have to choose the solution, the FluxMotor solution. You can rename it. And then you have the access to the FluxMotor catalog within SimLab. You can see we already have a lot of parts in SimLab 2025. You can choose the one you prefer, or the one that is more similar to your part. In this case, we choose quite simple parts. The name in me block 02C. You have to set the 3 structural parameters that we need to set within SimLab, that are the outer diameter, the inner diameter, and the number of poles. And in a few seconds, the new parameterized part will be available, as you can see. So you can edit the sketcher. For example, adding an hole if you want, or do some modification that can reflect your part in general. And you can see that we have all the constraints of the sketch in the sketch for all the lines and all the things we have in the sketcher. So you can create also new variables, for example, for the parts that you will create. In this case, is the diameter of the hole, and you can set a value. So once you finish the modification, you can close the sketcher, and yeah, the new part will be regenerated. Now we have to set the physics, so we set the magnets. You have to set the lamination and the air in the model. So we have to select all the faces that are made by air. Now we can use the checker. The checker gives you an idea of the parts, so gives you if it is correct or not. In this case, all the things are correct, but we don't have input parameters that are the parameters that we can change later in FluxMotor. So what we are doing here is, in the parameter role, you can change the role of the parameters and force them to be input, to have them in FluxMotor. We always need 3 parameters that are the structurals one, as I said, internal diameter, external, and number of poles. So we rechecked the part, and then you can export it, giving a name, a path, and you have to enable the parametric capability for sure if you have parameters then. So a new folder will be created. We will see later the content of this folder. Yeah. And once the part is exported, you can go to the part library within FluxMotor and import the part to selecting it. So the part is my magnet param and is imported. So now to use it, once we have the part in the library, we have to load the motor factory. And as usual, we need to set up the structural parameters, right? Because they should be the same. They should have the same values. So we have to go to the design topology, check or change if we need the outer diameter, the inner diameter, and the number of poles, because they have to be the same of the part that we exported. And then you can change the magnet shape and choose the one that you created. In a few seconds, you will see the new part that we created within SimLab and the parameters that we put as input. So you can change the parameters and the geometry will be regenerated. For sure, you can enter more parameter, you can add more parameter to be able to change, to better change your geometry. This is just an example, but yeah, this is how it works. Okay, so once you export the FluxMotor part, you will have a folder that is the same name of the part, and in this folder you will see the SimLab model, my magnet param, and in the view folder you will see a couple of images with the XML file. You can see a preview here. And this XML file is the one that is needed then to use the part in FluxMotor. So just a few words about warnings and limitation that can help you in performing your projects. So the first thing is the red points. So please check for red points. So red points often mean that the connection between two lines is weak, or so try moving a line and reconnecting it. Normally, as you can see from the image, also here below, we have some red points, but normally when you are ready to export the part, all the points should be black. This is not a specific law. I mean, it happens that also red points can allow you to create your part, but is something that we have to check, especially with the spline. For example, no spline, sorry for the error, but is mainly for imported geometries, and normally you will see a lot of red points along the spline. This means that you have to rebuild the line. Symmetry means that you should have the same points on the both sides, as here and here, for example, and no highland. No highland is a rule mainly dedicated to the thermal analysis. In fact, as you can see here, we have two holes, right? You can create your part with the two holes in a simple way, or you can add these three lines in the middle to be able to well discretize then the geometry for the thermal network. So it's just a thermal constraint if you want, but we normally recommend to have them and to avoid islands in your geometry. The last thing is please remember to add constraints. This is very important, especially in case of imported geometry and when the part is created from scratch. This is because if you don't add constraints, you will see some error, but also when you change then the parameter, you are not sure where is the versus of the change, right? So it's important that you remember to add all the constraints you will need. So for the moment in 2025, in SimLab 2025, the process is limited to the inner magnet part, as you can see. But in 2025.1, we already have the outer slot part type available. And as you can see some images here for the library and for the solution that we created. And also in the inner magnet catalog, you will have more and more parts to use. So yeah, we normally have a lot of things in the next version. So we are working a lot on SimLab, as you know. So thank you.